When you talk to an AI, it sounds so confident, right? It's fluent. It sounds like it knows literally everything. But then it says something that is just completely, utterly wrong, and it says it with total certainty. Well, welcome to database history. Today, we're digging deep into what I'm calling the AI truth problem.
So yeah, that's the big question, isn't it? Why does AI do this? Why does it hallucinate? And maybe even more importantly for our series, how do databases, of all things, end up being the fix?
All right, so to really get to the bottom of this, we have to start by properly defining what we're even talking about. Let's look at the AI truth problem. Okay, first thing you've got to get your head around is this. A hallucination is not a bug. It's not some simple mistake that engineers can just go in and patch up. No, it's a fundamental side effect of the way these large language models are built from the ground up. So, what does hallucination actually mean in this context? Well, here's the formal definition. It's when a model cooks up an answer that looks and sounds absolutely perfect. The grammar's right, the sentences flow, but the information inside them, it's just plain wrong. It's a complete fabrication, but it's a very convincing one. And this is the absolute core of the issue. Large language models, or LLMs, they don't store facts like an encyclopedia. They don't have a library of truths. What they store are patterns. So when you ask it a question, it's not looking up the answer. It's making a highly educated guess. It's predicting the most probable sequence of words that should come next based on all the text it's ever seen.
All right, let's peel back another layer and see how this really works under the hood. We're going to go inside what is, for all intents and purposes, a pattern engine, not a truth engine. This comparison really just nails the difference. Think about a traditional database, what we're calling a truth engine. It stores facts, hard, discrete facts in a table. You ask for something, it looks it up, simple. Now look at the pattern engine, the LLM. It's not looking anything up, it's just predicting the next plausible word. Its knowledge is all tied up in these complex mathematical weights. And here's the kicker. It has absolutely no way to verify its own answers. It can't check its work.
So to really hammer this home, the model knows the pattern of a sentence, not the fact inside it. Inside that neural network, you've got billions of numbers, these things called weights. And those weights might tell the model that the word Paris is strongly connected to the word France. But it doesn't store the actual verifiable fact that Paris is the capital of France. It just knows that in countless sentences it's seen, those words tend to show up together in a particular structure.
I love this analogy, it's just perfect. Think of an LLM, like that one student in your class who was a genius at writing essays, just incredible with words, but couldn't remember a single historical date to save their life. So when they get to a part of the essay where they don't know the answer, what do? They just guess. But they do it so beautifully, you almost believe them.
And here's the thing. It's basically forced to guess. The model's number one job, its core directive, is to produce the next word, or token in the lingo. It can't just throw up its hands and say, hey, I don't know this one, unless it's been specifically designed to do that. So whenever it hits a blind spot, a gap in its pattern knowledge, it has no choice but to fill it in with whatever seems most plausible. And that's how you get these invented legal cases, made-up scientific citations, all of it. Okay, so that's the problem, and it's a pretty big one, right? But now for the good part. Let's talk about the solution. And this is where, you guessed it, databases make a huge comeback, but in a really cool, modern way. The solution is actually surprisingly simple, almost elegant. We just give the AI something it was never built with in the first place, an external memory, a source of truth that lives completely outside the model's own brain. And this external memory usually comes in three main flavors. You've got your classic SQL databases for the hard, structured facts. We're talking names, dates, prices, the stuff that has to be exact. Then you have NoSQL databases for the messier, more flexible context. Things like a customer's entire order history. And then, the real game changer here, vector databases. These are what help the AI grasp the meaning and relationships between ideas. Now, this entire strategy has a name, and you've probably heard it thrown around. It's called Retrieval-Augmented Generation, or just RAG for short. RAG is the bridge. It's the technology that connects the incredible storytelling ability of an LLM to the rock-solid, factual truth of a database.
So that all sounds great in theory, but how does RAG actually work in practice? Let's walk through this AI truth pipeline step by step. Okay, so here's the journey your question takes. First, your question gets transformed into a vector, which is just a fancy way of saying a string of numbers that represents its meaning. That vector is then shot over to the vector database, which zips through and finds documents that have a similar meaning. At the same time, the system might ping a SQL or NoSQL database to pull out any hard facts or extra context it needs. Then all of this stuff, the similar documents, the hard facts, it's all bundled up and given to the large language model along with your original question. So now when the model generates its answer, it's not just guessing based on its internal patterns. It's building its answer using the real verified data we just handed it.
I think this quote sums it up perfectly. RAG basically turns an LLM from a creative, sometimes unreliable storyteller into a diligent researcher. It's not just weaving a tale anymore. It's looking at evidence, citing its sources, and building a conclusion based on actual information.
Now look, RAG is amazing, but it's not a magic wand. It's not a perfect silver bullet. And that brings us to the next big question. What's the future for creating AI systems that are truly 100% reliable? Because RAG can fail. Remember, the whole system is only as good as the data you feed it. So if your databases are incomplete or out of date, you're in trouble. If your vector database isn't indexed properly, it won't find the right stuff. Sometimes it just grabs totally irrelevant information and hands it to the model, which just gets confused. It really drives home the point that good old-fashioned data engineering is just as critical as the fancy AI model itself. And you know what happens when that RAG pipeline breaks down? The model just does what it was originally designed to do. It reverts to its factory settings, falls back on its own internal patterns, and it starts guessing again. We're right back where we started. So that really brings us to what's next, the next big frontier, and that's creating AI that can actually check its own work. Just imagine a model that before it ever gives you an answer, it automatically runs its own internal checks. It queries the SQL database to double-check a fact. It queries the vector store to confirm the meaning is right. It even checks system logs to get the full context. And, this is the most important part, if it can't find data to support its answer, it just says so. It refuses to guess.
Yeah, that's really the holy grail, isn't it? We don't just want an AI that can access facts. We want an AI that has a kind of intellectual humility. The real future is building an AI that knows when it doesn't know. Thanks so much for joining us on this tour through database history. If you're into this stuff, make sure you subscribe for more deep dives into the tech that powers our world. And I really want to know, what is the wildest, most bizarre, or just plain wrong hallucination you've ever seen an AI come up with? Let us know in the comments.